Hi, and today we're going to finish up our lesson 2-3. Today we're going to talk about probably the most important measure of spread, and that would be the standard deviation. We're going to learn to take or remind you how to find the standard deviation by hand. I believe you've done that in your Algebra 2 class, but we're also going to show you how the calculator can help you and what exactly the standard deviation is and what it means. So I have here some totally fictitious data, 28 ages of teachers here at Clio High School, and I'm going to ask my calculator to select 6 of them at random. You've used this technology before. Oh, can't use that one, got to repeat. Oh, this is good. We've got 6 different teachers' ages selected here. We've got the first teacher, who is 23. I'm going to write them and graph them. So I selected this one. The 12th teacher, well, let's see, I got 8 and 9 too. Here are the 6 that I selected, at least their ages. And let's take a second and graph those ages. So we have a 23, a 26, a 28, a 30, a 38, a 40, and that's it. All right, so I have my 6 randomly selected ages graphed, and boy, I certainly got young ones for my 6. I want to enter those ages into a table on the next page, and then we'll find a standard deviation. So here are my 6 ages entered into a table. The case is the teacher number in this case, and then the X value is actually their age, so those things are entered in. To find a standard deviation, we need to find the deviations from the mean, the differences from the mean. Those are called the deviations. We're going to do that for each of our 6 ages. Those are going to be the basis for finding that standard deviation. Whoops. So let's find those deviations. First, we need to have a mean. So I'm going to put those ages into my calculator and find an average. And for the 6 teachers I selected, the average age was about 30.83, as you can see. Now I'm going to go ahead and find the deviations. We have our deviations all figured here, some below the mean, some above the mean, because that's how averages work. If we were simply to add the deviations together, we get something that's very close to 0, since, again, we are using the average of the 6 ages that we had here. So just adding those deviations is not enough to find a standard deviation. Instead, we need to do a little bit more with. So here's a formula for standard deviation. The letter that we use is S. When you see it on a calculator, it will say S sub x. And that formula is this. It's the square root of the summation of, so there's the sigma, all of the x minus x bars, which we just found, all those deviations squared, and then a standard deviation averages that by dividing by, in this case, since we're talking about a sample, n minus 1. If we were talking about the population of all the teachers, see, we only have a sample of 6. If we were using the population of all the teachers, we would divide by n, and we'll talk a little bit more about that in class. But this is the formula for standard deviation. Just by the way, the square of the standard deviation before you take the square root is called the variance, and that is also variance, V-A-R-I-A-N-C-E. That is also a measure of spread, but it's more convenient for us usually to talk about the standard deviation. We are going to now complete our calculation of the standard deviation for our 6 ages by squaring, summing, and then taking the square root. So I'm going to ask you to pause the video, take each of these deviations, square it. When you are finished, sum, and then finally we will take the square root to find the standard deviation. I have a sum of 228.7534 because I carried all my precision. That is my sum, and I'm close to finding a standard deviation, but I'm not quite there. According to the formula, we divide by 1 less than the number of data items if we are using a sample, and we are. We had 6 data items, so we divide by 5. And let me just do that, dividing by 5. That value, 45.75, before you take the square root, that's the variance of this data set. And then its square root will be the standard deviation. And we have around 6.76. Now it won't come to any of you as a surprise that your calculator will do this same calculation. It's part of the one variable stats. I have my 6 data values in the list of my calculator, my X's if you will. And if I stat, calc, and one variable stats, they are in list 1. Yeah, right there. See SX? 6.76. That's our standard deviation. So I'd like to have you just make a note of that. We know how to do it by hand. We've done it by hand before. But this is also in one variable stats. It's SX. Looking at the work that we did to find the standard deviation, I think that you will agree with me that a good working definition is the standard deviation gives you an average distance that some data value is from the mean. I want to have you come to the next slide, and I'd like you to put that down in writing. Standard deviation, a good definition for it is it's the average distance any one data item is from the mean. Average distance any one data item is from the mean. And keeping that in mind, I'd like to have you try this. Take a look at the data sets here. Thinking about average distance from the mean, let's match them up with their correct standard deviations over here. Will you pause the video and do that right now? Here are my matches. That first data set, there is no deviation. That means that 0 would be its average standard deviation, if you will. As far as the numeric values here, the mean is 3 for sure, but we have in this set 2 items that are quite far from the mean. The average distance that any one item is from the mean is this, 1.51. This one, where data items are 1, 2, and 2 much closer together, will have the smaller standard deviation. Very good. The last thing I'd like us to think about today is finding the standard deviation for a set of grouped data, if you will. That is where the data items have values, but they each happen a given number of times. We'll see that the formula and the thinking are very much the same. To find the mean in a grouped data set, you still need a summation of all the data value x's times, however, the number of times that they occur, so times frequency and divided by the number, the total number of data items you have. The standard deviation formula, again, will be very similar here. It still calls for a summation of x minus x bars squared. However, we recall that each of them has happened f number of times, then divided by n minus 1 if we are under a sample. And that's where we're going to be for a while. So we've got a little data set here for you to work on. It says that you have 5 pennies. 5 is the number that you have of them. They are worth 1 cent each. So x is the value of a penny. We have 4 nickels. Nickels are worth 5 cents, but we have 4 of them. And we have 2 quarters. Quarters are each worth 25 cents. We have 2. I'm going to go ahead and work out the rest of my table following the formulas that I have above each column. I've multiplied each data value times its frequency, summed them up, got 75. We have 11 coins altogether, so the mean of our frequency table will be the sum of XFs, that's 75, divided by the number of coins, 11, and 75 divided by 11 is around 6.82. All right, from there we should be good to figure a deviance for each of our coin types, and then what we need to do to find a standard deviation is square the deviance and multiply by frequency. Remember that F is this frequency. I'm going to ask you to pause the video and let's do this work. Alright, I've done my x minus x bar squared times frequency real quickly. That 169.362 right there came from taking our x minus x bar, which was negative 5.82, squaring, and then multiplying by the frequency, the number of times it happened, 5 times. I added those up. I have 843.6364. My variance will be that sum divided by 1 less than the number of coins. So I'm going to be dividing by 10. And you can see that I've done that in my calculator already. My variance is about 84.36. To find a standard deviation, we need to complete this by taking the square root. So the square root of my variance is about 9.18 cents. Okay? The average distance that any one of our 11 coins is from the mean is around 9.18 cents. So this also can be done in your calculator. The note says that you put x's in list 1, frequencies in list 2, and then it's one variable stats. Only this time, since you are using a list for frequency, list 1, comma, list 2. That assumes data values in 1, frequencies in list 2. I'm going to set that up in my calculator and we'll just verify. I have those x values and their frequencies in list 1 and list 2. One variable stat. We must tell it this time. Our x's are in L1, but our frequency list is list 2. Now we're going to use that guy. And then go ahead and calculate, and you can see about 9.18, which is exactly what we said. So that's a handy thing to remember. That's it for today. We'll ask you to get out there, do the U-try, and we'll work with standard deviation a little bit more tomorrow.